So today is 6-2 linear equations in one variable. Two things for this first part of the video is solving linear equations and solving linear equations containing fractions. So what exactly is a linear equation? It's something that looks like this. ax plus b equals 0, where a and b are real numbers and a is not a 0. So if you don't remember anything else, it looks like this. 4x plus 12 equals 0. So it's something in which you can manipulate the numbers and solve for x. Oh, and by the way, notice that x is only to the first power. It's not to the second power. If this were to the second power, it would no longer be linear, it would be quadratic. So remember that x is only to the first power. Okay, so the properties of equality are some things that you need to know when you're looking at solving an equation. So say I have 2x plus 3 equals, let's say, 11. The addition property says that I can add something to both sides. If one side equals the other, if I add the same thing to the left side, I can add the same thing to the right, and it will still be the same. So like for instance, in this case, I can subtract 3 from both sides, and this would still be a valid equation. So this would be 2x, the 3's cancel, and now I have 8. So that is an example of the addition property of equality. Now if I move on down here, I still have 2x equals 8, and it will still be equal if I multiply or divide by the same number on both sides. We have c here that's being multiplied by a and b. Well, in this case, I'm going to divide by 2, which is the same idea because I'm actually multiplying by 1/2. So the 2's cancel, and now I have x equals 4. So that is an example of both the addition property of equality and multiplication property of equality. So what I want to do is use these properties to solve these equations here on the page. So on this one, I'm solving for x. -3, it's being subtracted by 3. So instead of subtract, I'm going to do the opposite of subtract. I'm going to add 3 to both sides. So I have x equals 11. Here we're adding 7, so instead of adding, we're going to subtract. So I have x equals 22, negative. Here we're multiplying by 6, so the opposite of multiply is divide. So we're going to divide by 6, so x is 5. And on this one, x is being divided by 5, so the opposite of divide is multiply. So I'm going to multiply by 5, and x equals 45. So those are using the properties to solve those simple equations. So basically, here are the 4 basic steps that you need to take to solve a linear equation. First of all, you need to simplify by removing grouping symbols and combining like terms on both sides of the equal sign. Once you're done with that, you can move all the variable terms to one side of the equation, and all the constant terms to the other side. And then you get to the point of isolating the variable and solving it, and then checking your original equation. So on this particular one, the first part, like we said, was to get rid of the grouping symbols, and here we have grouping symbol here. So that tells me that I'm going to actually multiply this 2 through by distributing it to eliminate the grouping symbol. So I have 2x minus 8 minus 5x equals -5. Now, the right side of the equation is already simplified. There's only a constant there. On the left side, I need to simplify that, and I can do that by putting my 2 x values together. I have a positive 2x and a -5x. This makes it -3x minus 8 equals -5. And now I want to isolate the variable here, which is x. So I need to move everything away from it. And I'm going to move this constant away from it first. We have a -8, so I'll add 8. So I have -3x equals 3. And now I can divide by negative 3. These cancel, and I have x equals negative 1. To check this, I can put this back into my equation and make sure that it is actually valid. So I can say 2 times negative 1 minus 4 minus 5 times negative 1 equals negative 5. So negative 1 minus negative 4 is a negative 5. And negative 5 times a negative 1 is a positive 5. And now I have negative 10 plus 5. And it does turn out that the left side equals the right side. So this is indeed a correct solution. So now let's try the second solution here on the second equation on the right. Notice I have my equal sign here, but I have an x term on both sides and I have a constant on both sides. So I need to get all my x terms together, and I can do that by subtracting 8x from both sides. And I need to get all my constants together, so I'm going to move that one over here. So this is a negative 12. I'll add 12 to both sides. When I do that, I have negative 3x. These cancel, and then on this one I have 36. Now to get x by itself, I'm going to divide by negative 3. Now x is equal to a negative 12. Let's check to see if that is indeed the right answer. So 5 times negative 12 minus 12 equals 8 times negative 12 plus 24. 5 times negative 12 is negative 60 minus 12. And 8 times negative 12 is negative 96 plus 24. So 60 and 12 together is negative 72. And negative 96 plus 24 happens to be also a negative 72. So this is the correct answer. I have 2 more examples here. This one's a little bit harder because now we have distributive property that needs to be done on both sides of the equal sign. So that's the first step that we're going to do. 2x minus 6 minus 17. And then I can combine these 2 terms, so that'd be 2x minus 23. On the right side, I have a negative 3x and a minus 6. I can combine this term and this term. So 13 minus 6 happens to be a 7 minus 3x. Now notice we have x's on both sides and constants on both sides. So I'm going to move negative 23 to this side, and I'm going to move 3x to this side. I'm going to add 3x to both sides. I'm going to add 23 to both sides to get rid of that 23 on the left side. So this cancels and this cancels. I now have 5x equals 30. If I divide both sides by 5, I now have x equals 6. So once again, you can check it by placing the 6 into the x value. So if we do that, and we put it through in our calculator, we'll have 3 times 2 is 6, minus 11 is a negative 11. On this one we have 8 minus times a negative 3 is negative 24. 24 minus 13 is a negative 11. So that is correct on both sides. Now here we have fractions, and I know that I hate dealing with fractions, so I can only imagine that you guys would hate dealing with fractions. So let's get rid of them. And the best way to do that is to find a common denominator. Here we have a 2 and a 5. So let's multiply the entire thing by 10. Because when we do that, that will get rid of the fraction. So I'll take 10 times this, and this, and this. So 10 times 3 is a 30 over 2. 10 times 8 is 80 over 5. Oops, that should be a 0. And 10 times 39 is 390 over 5. Now what we can do is actually divide each of these coefficients by the denominator, and you won't have a fraction anymore. So 30 divided by 2 is 15x. 80 divided by 5 is 16x. So this is 16x. And if we take 390, okay, so this is 78. Now notice that we have x's on both sides. So what we're going to do is actually move one of them over. We're going to move that 16. So I subtract 16 from both sides. And now I have negative 1x equals negative 78. If I divide by that negative 1, I have a positive 78 on both sides. And we can check our work once again by replacing the x's with the 78, but I'm not going to take the time to do that right now. Now, one last thing we need to look at is some application problems. And this one is based on humor. So the belief that humor and laughter can have positive benefits on our lives is not new. The graph on figure 6.2, which is this right here, indicates that persons with low sense of humor have higher levels of depression in response to negative life events than those with high sense of humor, which makes a lot of sense. But here are the two formulas that represent this. So this is the low humor group, and this is the high humor group. And since we have an intensity level of 3.5, we are wanting to look at this group right here. So this would be equal to 1/9 times 3.5 plus 26 over 9. So 1 times 3.95, divided by 9, plus 26 divided by 9 is a level of 3.3 about. So if I come over here to 3.3 and we look at the graph, this does come out to be pretty close to 3.3 on the graph. So here's the two models, and actually we just went through that here. We used this model and we put in 3.5 for x, and we found out the intensity was indeed 3.3. So that is the end of this video for today.